So that's a typical use case, right? You consent and the application displays your calendar, right? That is OAuth, right? The third-party application, ultimately the OAuth client is you've the user, the resource owner has delegated access to this third-party application to access its resources, right? So that's OAuth 2. It's all about authorization delegation on behalf of a user, or in some cases on behalf of the client, back-end service where the client is representing itself. So you got these four major players where you have, obviously you have the resource owner, you have the client, the authorization server, and the resource server. So high level, that's OAuth 2. But OAuth 2, it's only about authorization, has nothing to do about authentication. That's where OpenID Connect comes in. OpenID Connect builds on top of OAuth 2, just like all these RFCs, they all build on top of OAuth 2, and there's like so many of them. It's really overwhelming, to be quite honest. There's just so many. But anyways, OpenID Connect is the authentication piece. It builds on top of OAuth 2. And it provides this one main concept, or one main construct, the ID token, right? The ID token, it's a JWT, JSON Web Token, that ultimately has claims of the authenticated user at the provider, right? So for example, every resource owner or user has a unique identifier, and that's ultimately identified between the issuer, which is unique identifier of the provider, the OpenID Connect provider, and the subject, which is the unique identifier of the user within the provider. So the issuer and the subject is a global unique identifier of that user, right? That's in the ID token. There's other claims there. We're not going to get into all of it right now, but ultimately that ID token, the client uses that ID token as part of the OpenID Connect flow to ultimately verify that the ID token is valid and obtain information about the user and ultimately authenticate the user into the application. And I kind of already referred to the ID token is a JWT, a JSON Web Token. Right? It's just that it's a type of access token. There's different access tokens. It could be opaque, could be self-contained, like a JWT. Self-contained, as in an access token has the client or the resource server. The access token has claims about the access token, right? So it describes, authorization metadata associated between the client and the authorization itself, and there's claims within the JWT. JWTs could be signed. That's where JWS comes in. And the ID token, as part of the specification, has to be signed. And then you got JSON web keys, right? How do you verify the signature? So the authorization server exposes a JWK set endpoint where resource servers and clients could obtain the public key to ultimately verify the signature, right? So that's it, right? That's a really high level rundown of the main specifications that are implemented within Spring Security, and I'm going to refer to these and show examples of it as we go through the demo. So the rest of the demo is basically we're just going to be demo and code, right? So let me just show you um, what this sample is all about. This is a really high level architecture diagram, application architecture diagram of the sample. Right now we have the UI app, right? This is where it's standard web application, thime leaf application, an OAuth client application that ultimately calls different resource servers. Right, we have microservice A, microservice B, and microservice B calls microservice C, right? As in, this is a typical use case where, you got a client application, whether it's a mobile app or a web application, that, potentially calls multiple resource servers to ultimately aggregate the data and ultimately display it in the UI, right? But then you also have resource servers that call downstream resource servers to gather more data, right? And this chain of calls between microservices could be quite deep. It all depends on the type of application, right? Enterprise grade applications like banking applications, you probably got multiple, call chains happening, right? And just complex interactions. But ultimately, everything goes through this UI app, right? You want the one interaction coming to the UI app, and then the UI app fans out to the different services, right? To gather data. And then obviously you got the authorization server where you get the tokens, right, to be able to call the resource servers. So this is what the sample is all about. We got three resource servers, these microservices. We got the UI app, which is the client application, and then we got Spring Authorization Server here. All right. And what I'm going to demonstrate in this application is one specific flow, because this sample is all about different flows, right? Standard flows that you see in enterprise, in enterprise apps, right? And best practices on, what type of token or what type of grant that you would use in specific flows, right? So if I were to jump into, the application, just to give you a quick I'm going to log in here. And the idea is right now, this is a working application, right? Everything's working right now. But what we're going to do, and I just want to give you like a quick tour of this application and the goal of this application. And then what we're going to do is we're going to basically strip security right out, right? And then we're going to incrementally build the security back. But right now, I want to show you what the whole purpose of this application. As I mentioned, this application is really demonstrating, common flows. So here we have a very basic flow, right? You have a web application that calls one microservice. Then we're building here. We have another flow where we have, the client application calling two services, right? Then we have this token relay. This is a pattern that's used. I'm going to get into this a little bit, but this is a common pattern that's used where ultimately the UI app, the client in the UI app, obtains a token that is able to call three different services. Right? It calls service A, then it calls service B, and then service B relays the token to service C. Right? Token relay. Token exchange. This is a much better pattern, or as far as best practices and more secure. Token relay in certain scenarios I would not use, and I'll get into those details later on. But token exchanges, instead of relaying the token from service B to service C, it'll exchange the existing token for another token that has lesser privileges, right? So ultimately, it's more of a secure interaction between service B to service C. Then here we have a client credentials grant flow where service B doesn't exchange the token before it calls service T. It gets a new token, right? And it's calling a system service, right? Using the client credentials grant, because that's where the client credentials grant comes in. Is you want to call, to use an example, an inventory service. An inventory service, you don't need user context. You just need to check, is there inventory on a specific product? So in this particular case, you just need a token, using the client credentials grant. The client represents itself, and it basically, you obtain the token using that grant, and then you call the inventory service. And I'll get into those details, but this is the flow that I'm gonna demo, because I can't do all five of these. There's definitely no time. We're gonna focus on this client credentials flow, right? So if I click on this right now, all right, there's the consent screen, right? Client A, B, and I'm gonna get into the naming conventions of these, right? Because the biggest thing that I did not want to do with this sample is I did not want a domain model. I didn't want to create a shopping cart or whatever, because it's just noise. Like, the whole purpose of this sample for me that I was trying to get across is demonstrating flows, right? It's really just about, how do I hook up an OAuth client, a resource server? What grants do I use between these different interactions between these services? And so there is no domain model. It's really just the display. Actually, I'll just jump to this next screen and we'll show it. But keep this in mind: is client AB, right? Client AB, microservice A, microservice B. Client AB is able to call microservice A, microservice B, right? Because it requests authority B, which microservice B authorizes on. Microservice A authorizes on authority A, right? You get it? So that's kind of like the naming conventions I've used. And when you go here, right, this just gives you this kind of introspects, you could say, the flow, right, and the authorization metadata that is flowing between the different interactions. For example, here the UI app, right? Here I got flow ABC, right? Flow ABC ultimately is, the UI app calls microservice A, um, calls microservice B, and then B calls C, right? So flow A, B, C, right? And then you got these three different calls here, right? So here's the UI app calling service A. This is the token metadata, right? Ultimately the claims, right? This is the JTI. This is the unique identifier of the JWT, right? Here are the authorities associated with the JWT, and we requested authority A and authority B, right? Now this scope here, this basically is the default prefix for scope authorities, right? This authorities comes from Spring Security's authentication object, right? There's a one or more authorities associated with authentication. Typically you see role, like role user, right? But in OAuth we give it this prefix, the default prefix scope, to indicate this is a scope type of authority, right? Then we have the subject. This is my username. This is my unique username within the provider that I logged in. And then we have the audience claim with the audience of this token, right? Client AB is the one who requested access to users one resources, right? So this is the client identifier, right? And then here we have the call to service B. As you can see, it's the same token, right? But over here, service B that calls service C, you could see the token's different here, right? This because we're using the client credentials grant here, right? So this client here, client C, did another flow, authorization grant flow, using the client credentials grant to get a token. And here, it was just requesting authority C, right? Because it needs to call service C. Service C authorizes on authority C, and that's the only scope that it needs. So that's tight, right? As far as from a security standpoint, um, you know, I only got one scope associated with this token, right? Token relay would have been different, right? We would have had three authorities, three scopes associated with it, and then I'm just relaying the token, and that's not ideal in that specific scenario, because service C doesn't care about authority A or B. Furthermore, if that token gets leaked, any client could use it because it's a bearer token, right? So ultimately, you just opened up the attack surface to three different microservices. So this is really what you want to do when you're interacting between different services. Is you really want to obtain a token with least privileges, right? But enough to access that one service and nothing more, right? So that's kind of one of the flows, one of the best practices, um, for interaction between different services. So this is it, right? So this is the app, right? This is one of the flows, and now what I'm going to do, and this is just some extra information. I logged in, right? There's an ID token, right? As part of OpenID Connect. Here are the claims, right? I was mentioning the issuer and the subject, right? And then here are the different client registrations, right? Different clients I have in the UI app. As you can see, we authorize client AB. This is my login client, my OpenID Connect client. I could view the tokens here. I could view the access token, the ID token, and we're going to get to this as we're building the app. So what I'm going to do now that I kind of just give you a quick a tour of the app, I'm going to basically strip security out completely, and then we're going to incrementally build it. Let's do that. So next thing I'm going to do here, let's check this out. Okay, and then I'm just going to do some restart this here. I hope I'm talking at a good pace and not too quickly. All right, so now we're basically at a point where we don't have any security, and let's just confirm that. I like to start fresh with a new window. Right, so there you go, right? So I didn't get the login screen, right? So I'm able to access, there's authentications completely disabled. If I click on this, there's no consent screen, and as you can see, there's no data either, right? So now we're at a point where, the 3 microservices are unsecured. I could access them. Um, if I try to access, one of the services here, service A, there we go. That's open, right? This is microservice A. This is the metadata that comes back, and that's ultimately displayed in the UI app. So now this is where we're at. So now the first step that we want to do is obviously we want to start with authentication, right? So how do we enable OpenID Connect in the UI app with Spring Security? Let's start there. So the first thing we got to do with any Spring Boot app, right, is add the dependencies. These are the main dependencies for OAuth 2 client. These are the 2 starters, right? Spring Boot starter security, obviously, and then OAuth 2 client, right? Like any Spring Boot app, to enable the auto configuration, it's pretty standard. You add the dependencies, and then you add the properties, right? Usually, those are the 2 that typically trigger auto configurations. So for OAuth 2 client, these are the 2 starters. Now, obviously, you could see that it's there. But what I've done, I've disabled the auto configuration by adding it, by excluding it in the Spring Boot application annotation here. As you can see, I've disabled security auto configuration. This is the Spring Security auto configuration. And then here we have OAuth 2 client auto configuration. By default, OAuth 2 client auto configuration will configure OAuth 2 login, which is OpenID Connect for OpenID Connect providers, and it'll enable OAuth 2 client support, right? So I'm going to remove this, all right, and then I'm going to go into my application YAML here, and then we're going to add properties here. So let's take a look at this here. So these are my properties. Base property path is Spring Security OAuth 2 client registration, right? And now I could add multiple clients here. I just got one right now. We're gonna end up adding another one, later on. And this is really just a logical identifier. I could name this anything I want, right? But I'm gonna give it the name login client. This is ultimately my client that is gonna perform OpenID Connect authentication, right? Here I have the provider, right? So I can have multiple providers here. Right now, we're just using Spring Authorization Server, but I could have an OAuth client application where, maybe I'm accessing, some Google APIs as well, right? Then I could add, a Google, Google provider ID with its issuer URI, or maybe I want to be more specific and add, the different endpoints, the authorization endpoint, token endpoint. The issuer URI here is, you know, if I go to, I'm gonna go to, where are we here? Yep. So here, so this is basically OpenID Connect Discovery. Okay, now some providers, OpenID Connect providers, even OAuth 2 providers too, there's an OAuth 2 specific spec for this, is it will expose a provider configuration endpoint. So basically configuration for the provider, as in where our, you know, I mean, the most common, the the most common ones are obviously the endpoint URIs, right? So we have the authorization endpoint, the token endpoint, you know, the authentication methods that are supported on a token endpoint. This is basically where the public keys are exposed on the provider, where the client or the resource server would fetch the public keys to be able to verify the signature on the JWT and so forth, right? So, you know, this is what Spring Authorization Server supports currently, these specific configurations, and as we incrementally build features, this will, you know, this will expose more information, right? But ultimately, this allows a client or a resource server to ultimately self-configure itself, right? Which is super convenient, because here I'm just, you know, providing the issue, right? Instead of, you know, I would have to do something like this, you know, and provide, you know, each specific endpoint. If I didn't have the issue URI, you know, I would have to provide each individual one in order for the client to know where to, you know, redirect a user to the authorization endpoint, or where to exchange, you know, the authorization grant for the access token, right? So this really is super convenient, where I just specify this, and the client will ultimately fetch, you know, those pieces of information, the authorization endpoint, token endpoint, the JWK set URI, and auto configure itself, right? So that's super convenient, right? That's ultimately um, the provider configuration endpoint. And then here we go. Then we have client credentials, right? The client has to authenticate with the token endpoint and able to exchange the authorization grant for an access token, right? And here we're just basically specifying client credentials. You know, I mean, there's always the client identifier, but if the
The
client,
teacher.
sorry, if there's a question, let's definitely, I'm gonna definitely stop at the end of this, and then I'll you know, I'll ask if anyone wants to ask any questions. Okay, great, thank you. So over here, you know, we've configured client credentials, because client's going to authenticate using HTTP basic post, right, and using these credentials. The redirect URI here, right? This is the standard redirect URI pattern for OAuth 2 login within Spring Security Auth Client. So this is ultimately where, if you recall the consent screen, when I clicked on authorize, yes, I authorize this client to access my resources. Ultimately, the authorization server redirects the authorization grant, which is, you know, when it comes to the authorization code grant, the authorization grant is the authorization code, which is a temporary credential that could be used one time to exchange it for an access token. So the authorization server will redirect the user agent back to the client application at this redirect URI with that code. And ultimately, this client will use its credentials to authenticate to the token endpoint, passing the code, and ultimately getting the access token. All right. For OpenID Connect, the OpenID scope is required. This is ultimately what triggers OpenID Connect authentication. This implementation of OAuth client and OpenID Connect uses the authorization code grant. So if I actually didn't have OpenID here, it would just fall back to the standard OAuth 2 authorization code grant. So those are the properties, right? So literally what I've done to enable OpenID Connect authentication is all I got to do is add the dependencies, right? And then add the add the client registration with with this minimal set of configuration. There's more that could be specified, but this is your minimal, right? So let's see what happens. I'm gonna start this up right now. I'm going to restart my app, and I'm expecting to get the login screen and ultimately go through the authentication flow. So let's start. I'm going to start a new window. I like to just keep always start a new incognito and just kind of start fresh. All right, there we go. So I did get redirected, but let's open this up and start that over again just so we could see. Okay, there we go. So I get the login screen. Let's see what happened here. So I went to 8080. I got redirected to so the client application, so automatically when there's with Spring Boot auto configuration, if there's one client registered, it will automatically trigger the authentication. And the way it triggers it is it basically calls the base path OAuth to authorization, and the last part of that path is the client registration identifier. As you can see, login client. That's what I used in my properties. I named it login client, right? So this is the client that ultimately is used to perform OpenID Connect, right? So what happens here? Another redirect to the authorization server. And this is ultimately the authorization request, right? So now I'm at Spring Authorization Server. I haven't authenticated yet. I'm going to authenticate with with the provider using my credentials at the provider. And there we go, right? So now I'm authenticated, right? And just to prove that, I'm going to go to the session state, and here we go, right? Here we have so the ID token is what I was referring to earlier. The client uses the ID token, which comes back on the token response. So when the client does the exchange of the authorization code for the access token, what also comes back on the token response is the ID token. And the client uses that ID token to ultimately verify the claims of the user and authenticate the client to this client application, the UI app, right? Um, and these are the claims, right? So here's the subject, this is the unique identifier of the user, right, at the provider, at this issuer, and the subject user one. Obviously the audience is the client, right? So this is the audience of the ID token, and there's my session identifier, right? And here we have the one client that we have authorized so far. Let's take a look at the ID token just so we could see what it looks like. I'm gonna go to the JWT here, IO, so we could see what claims are in the ID token. So here we go, right? So these are the claims that are on the IT token. So here we have the header. JWT has three parts: header, claims, signature, right? Here we have the KID, which is the key identifier. So this is the identifier of the key that was used to sign the JWT using this algorithm, an RSA key, 256 hashing algorithm. And then here are the claims, right? Subject, the audience, authorized party, the party who's authorized to access to use this token, the issuer. Here we have the expiry of the token, the time it was issued, nonce, which is part of a claim part of OpenID Connect. It ultimately allows the client to correlate the authorization request with the token response. And then we have the signature here. So this is what the ID token looks like, the standard claims. So that's pretty much it for the authentication. Just to give a recap there, all we really needed to do is add the dependencies and then add the properties, right? So that's it. That's OpenID Connect. I want to take a pause right here and see if anyone has any questions before I continue to the next section. see if there's anything in the chat just to make sure. Okay, I think everyone's okay. Yeah, I don't see
Oh, hi,
anything.
Joe. This is Sunil. I have a quick question. Is
Sure.
more related to the um, authorization mechanism itself. What are your thoughts on using Availity or other commercial vendors?
Sorry, I didn't get that last part. Using a commercial product,
Right,
providers.
like Availity or SiteMinder for
Oh,
authorization.
yeah, I can't really comment on other products, but I will say this is don't write your own provider. Definitely, definitely do your research and buy a proven provider that's going to stand by, first of all, one that's been around for a while, one that fixes vulnerabilities very quickly, one that has support, um, and yeah, you do not want to be in the business of you know um, creating your own provider. I mean, Spring Authorization Server, ultimately the goal of Spring Authorization Server is to allow products to, OpenID Connect providers or OAuth providers to build on top of Spring Authorization Server. But, Spring Authorization Server, just like OAuth 2 Client, this is a framework, right? It allows you to build the product, right? So, one of the main use cases of Spring Authorization Server is to allow developers to stand up an authorization server so they could test their client and resource server application. That's really like number one use case. However, you could also build a provider on top of it. And I certainly hope, when we push out, the major release, products will be built on top of that. But like I said, if you're gonna build a provider and put it into production, you really need to ensure that you got the support there, especially when vulnerabilities pop up, and you really want to use a proven provider. So I'm not going to comment on SiteMinder or Okta or these products. I definitely have a couple that I favor myself, but that's ultimately the decision of the information security teams to decide on, right? Which provider or which vendor they're going to go with.
Yeah, sure. Thank you.
Hi.
No worries. I could take one
Hi.
more
Hi.
question if there's, yep.
Hi. This is Sanjay. I have another question. For the enterprise systems, right? Mostly people use Kerberos authentication system for authentication, right? So how does this support? Can we use it here in Spring 5 or Security 5, or is not supported?
Well, I mean, so there is an issue that we're gonna like provide some samples in the Spring Authorization Server GitHub repo. one thing to keep in mind is Spring Authorization Server provides support for the authorization server role, right? And within OAuth 2, and within OpenID Connect. But as far as the authentication system or subsystem, ultimately where the users reside, right? Whether using Kerberos or LDAP or SAML, Spring provides integration, right, with those different types of security protocols, authentication protocols, right? So Spring Authorization Server or Spring Security already, I mean, there's Spring Security Kerberos, right? So you would integrate Spring Security Kerberos with Spring Authorization Server, but ultimately Spring Authorization Server would delegate authentication to the integration with Spring Security Kerberos and the backing system, right? So that's totally all doable, right? But that's not the responsibility of Spring Authorization Server. Spring Authorization would delegate authentication to the Kerberos subsystem or whatever authentication subsystem is in place within the enterprise. Does that make sense?
Yeah, sure. Thank you.
Cool. Okay. I'm gonna continue, but we'll definitely keep answering questions. But I just want to kind of move on, because I'm just doing a time check. But let's move on to the next step, if everyone's okay with that. Okay. So we got authentication. So if we go back to our diagram here, right? So we have authentication happening here, OpenID Connect authentication on a UI app. What I want to do next is I want to be able to call microservice A and microservice B, right, with an access token, and to be able to act and ultimately start filling in that data on that screen right here, right? As you can see, it's all empty now. I want to fill that in to show that we've secured microservice A and service B. We've configured the client on UI app, which passes a token, and this gets populated. So let's do that first. First thing we're going to do is we're going to enable security on microservice A and microservice B. So ultimately, we're going to enable a resource server. Let's do that first. And once again, standard with any Spring Boot app, the first place we're going to start is at our dependencies, right? So here for an authorization server, we're going to add the Spring Boot Starter OAuth to resource server dependency, right? So that's the first thing. And I did the same thing here with the Spring Boot application annotation. I've just excluded the specific auto configuration, which is OAuth to resource server auto configuration. So I'm going to remove this. So the auto configuration kicks in. And then, well, it's not going to kick in yet until I add the properties, right? So let's add that next, right? And same thing over here, right? Is I've added the issuer URI, right? Because, and I've enabled JWT. Now, we also, Resource Server also supports opaque tokens, but this sample is using JWTs. Resource Server is, expecting a JWT to come in, and it will use the scopes or the authorities in the claims to ultimately authorize access to the resources within that resource server. And we're providing the issue URI. What does the resource server need the issue URI for? It's got to validate the signature, right? So if we go back to the provider configuration endpoint here, all right, and this is where as part of the specs I was talking about earlier, JWTs, JWS, as in JSON Web Signature, and JWK, JSON Web Key, right? So over here, the resource server will get this endpoint here, the JWK send endpoint, and it will read the keys here. Now, JWK set endpoint, so JSON Web Keys. So it's a JSON representation of the public keys that the provider exposes so that a resource server or a client could use to verify the signature of the incoming JWS, right? There could be multiple keys here. There could be right now we have an RSA key. There could be elliptic curve key, maybe even a symmetric key, and so forth, right? But typically, there's one active key that the provider uses to sign. But with key rotation in place, there could be, one active key and one passive key. Passive key as in it was the previous active key used to sign JWTs, but it still needs to be available because there's access tokens or JWTs out there that have been signed with this passive key. So ultimately, the resource server still needs access to this key to be able to verify. But eventually, those passive keys go into inactive state, and they're no longer exposed in the JWK set endpoint. So this is what the resource server does. It reads the public keys from the JWK set endpoint using the issuer URI. So this is pretty much all you got to do for a resource server. Let's start this up, and we will confirm that this actually is secure. start to go to 80. I think it's 8091 and service A. Right. This is what I was expecting, a 401. All right. Let's do that again. And I'm going to show you here. As we can see here, we get a 401, right? So we know it's secured. And we could also see on the response header, the www authenticate header, and it says bearer, right? This is ultimately saying you need to authenticate with this service using a bearer token, right? So we've confirmed here that you know microservice A is now secured as is now a resource server, and it's secured by OAuth. Right, so that's pretty much it. Just like OAuth client, the main things is you add your dependencies, add your properties, and you're good to go, right? And by default, the resource server will only validate the signature. Later on, we're going to add more finer grained authorization rules, as in this resource server only allows JWTs that have specific authorities associated with it. For example, scopes, right? So we're going to get to that kind of at the end of this demo, where we're adding more fine-grained authorization. Right now, if the signature is valid and it's not expired, it allows it to proceed. It authorizes the request. Now let's quickly do the same thing with microservice B, because we got to enable this as well. So I'm going to just remove this. We're going to add our properties here. Same properties. We're going to restart this. And then we'll just confirm that this is as well secured. Okay. And we'll go to service B. That's what we expected. 401, same thing, right? Service B. Okay, so now that was pretty easy, right? Standing up a resource server, right? Now we got microservice A secure, microservice B is secure. They're both resource servers. They support JWTs. They verify the signature, and they ensure the token's not expired. And then they allow the request to proceed. Now we got to actually pass the token. So let's configure another client on the client app that's going to basically go through the authorization code grant flow to obtain a token that's going to have the specific scopes that microservice A and microservice B authorize on. All right, so let's set that up. Let's set up that client as the next step. So we'll go to our application YAML here. I'm just going to open up my little shortcuts here, and let's add another client registration here. Okay, so here now we got two, right? We have our OpenID Connect client, and then we have another client here, client ABC, right? Client ABC is requesting scopes, authority A, authority B, authority C. This is the redirect URI, right? Because with the authorization code grant, you need to specify the redirect URI. This is ultimately where the authorization response comes back with the authorization grant, the code itself. And everything else is pretty much the same, right? I mean, this looks the same as the login client. It's just a different client, different flow. But the key thing here is got OpenID Connect here. This is what triggers OpenID Connect authentication. Here, there's no OpenID Connect. This is just falling back to, well, it's not falling back. This is the OAuth 2 authorization code grant, all right? By default, authorization grant, all right? That's one of the properties, but by default, it just defaults to the authorization code grant. I don't have to specify that here, but we'll look at the client credentials grant where I actually do specify and I specify the specific grant, but by default, we are using the authorization code grant on this client. I'm just basically showing the absolute minimal configuration for a client configured for the authorization code grant. So there's my client configuration. Now I got to configure the actual web client. We're going to use web client as our HTTP client to perform the authorization code grant. So let's add that here. I'm just going to import all these quickly. I'm going to get into this a little bit because this is there's a bit involved here. If this is the first time you're looking at this, I'm gonna get into the purpose of some of these core classes here as part of the OAuth 2 client support. So let's start with the client registration repository. I mean, this one's basically the clients that we have configured. So this is the repository where the client registrations are what's the word I'm looking for, are housed. That's for lack of a better word. But ultimately, these properties here, as you can see, there's 2 client registrations. Spring Boot will automatically read these properties and it will create 2 client registration instances. And as you can see, these properties map to those properties, right? Client ID, client secret, authorization grant type, redirect URI, and so on, right? And it will create an in-memory representation of this specific interface, this client registration repository, right? So obviously we need, so that's where things start with OAuth client. It starts with the client registration repository. The second piece with the web client here is the OAuth 2 authorized client repository. So this is the repository where clients are authorized, right? We have the client registration. When a client goes through an authorization grant flow and is ultimately authorized, by the user, for example, in the authorization code grant, this is ultimately where the authorized clients reside, right? And what is an authorized client? I mean, this authorized client is really just an association class, right? Because during the authorization code grant, there's 3 parties, right? You have the client, you have the resource owner, and then you have the provider, right? And the result of that authorization at minimum is an access token, right? And as you can see here, we have the association, right? We have the client registration, the principal name. This is the unique identifier of the resource owner that authorized the client, right? Then we have the access token, right? Which is the result of that authorization grant flow. We have an optional refresh token depending on the grant and depending on what's configured on the provider for the specific client. There may be a refresh token that could be used to refresh an expired access token. All right, so those are the 2 central interfaces within OAuth client. You have the client registration repository and the client registrations it houses, and then the authorized client repository where clients have been authorized and where the authorized clients reside, and ultimately the access tokens, the credentials used by the clients to access resource servers. Right, so that's the high level of those 2. Now, I need an HTTP client to call a resource server, right? And ultimately, I want to be able to create a request that associates, that adds the authorization HTTP header with the bearer scheme, and and ultimately the access token, right? So that way, I'm making an OAuth 2 protected resource request using an OAuth client, right? So how do I do that? With Spring Security OAuth support, OAuth 2 client support. So this very long name, servlet OAuth 2 authorized client exchange filter function, is really has all the built-in features for OAuth 2 client support, right? As in it um, it has a reference to the client registration repository and the authorized client repository via an authorized client manager. All right, so the authorized client manager, as you can see, this gets injected, right? This bean here is creating this authorized client manager, and its sole responsibility is to authorize clients, right? Using clients in the client registration repository and and register the authorized client in the authorized client repository at the end of each flow, right? This is the role and the responsibilities of the authorized client manager, right? And as you can see here, I'm configuring for this specific flow, I am configuring a client for the authorization code grant flow, and I'm also enabling refresh token, right? Because I happen to enable refresh token support for my client here, right? So I'm enabling these grants for this manager via a authorized client provider, right? So the relationship here is an authorized client manager has one or more authorized client providers. These providers ultimately are an implementation of an authorization code grant flow. So this is where, authorization code grant would get implemented, or client credentials, or refresh token, or JWT bearer grant, token exchange, and so forth, right? When we start adding these different supports for these different grants, these extension grants. But for this particular flow, just authorization code grant, and I want to be able to refresh my expired access tokens. Right. So this is how you would configure an authorized client manager with its associated providers. And this is what this really long, name, the servlet OAuth 2 authorized client exchange filter function. So web client, part of Spring Framework, it uses exchange filter functions. If you're familiar with REST template, it's kind of like an interceptor, right? You could pre-process requests, and you could post-process responses, right? And this is ultimately where we want to plug in, right? We want to be able to plug in when a request is created. We want to be able to pre-process that request before it's actually initiated and add the access token into the authorization header. And this is all you really need to do, right? Is create an instance of this exchange filter function, pass in the authorized client manager, and then just apply it as a filter to this web client. This is pretty much standard configuration for OAuth client support. The only difference in the configuration is maybe you want to enable client credentials, right? Maybe you want to enable password grant as well, right? It just depends on your flow, right? Ultimately, in one of those clients, when service B calls service C, I'm going to configure this, just the client credentials grant, but we'll get there. Let's revert that back. Just doing a time check. We're definitely running. Yeah, we're running. What time do we have, by the way? I was planning on going another 10 more minutes. I could go longer, but how long do we have scheduled there, Courtney? I can't recall.
It is currently scheduled till 7. I would just say though, of course,
Just
what you're
keep
saying is super relevant. So I would just keep going, and if people
keep
have to
going.
hop
Okay,
off, oh,
that makes sense.
oh yeah,
Okay,
if people hop off, they hop off. And if you have a question that's pressing and you have to log off, maybe pop it in the chat and Joe can answer it before you go. But otherwise, I would say keep going, Joe.
sounds good. Okay. I'm gonna add this here now. This is also, I mean, now that I've configured web client to have OAuth client support, how do I trigger, how do I target a specific client that I've configured to go through the flow and get an access token, right? And this is one method of doing it. I'm going to show you a couple of methods. So we have this this argument resolver, with Spring MVC called registered OAuth to authorized client, right? This will ultimately resolve this specific client. Now, this is the registration ID, right? Now, as you can see here, go back to what I added. This is my registration ID, client ABC, right? So I'm targeting this specific client registration to go through the flow, right? And ultimately, what I want to be able to, like, I need the access token, right? So the way I get the access token is via the authorized client, right? Because that's where the access token, there it is, right? So I just want to basically trigger that flow, and then I want to get the access token, right? So the very first time I call this endpoint here, flow ABC, it's going to trigger the flow, right? Using this annotation, it's going to see that client ABC is not authorized yet, and then it'll just trigger the flow. It'll go through the authorization code grant flow, we'll get the consent screen, and then it'll come back, get redirected back to here, and now it's going to be able to resolve the authorized client, right? And now that I have the authorized client, I'm going to go, actually, I'm going to change this before I forget. I'm just going to add this here. I'm just going to say, okay, now that I've resolved it, how do I actually use it, right? Now let's look at this specific line of code here, my web client, this specific line right here, right? Everything else is the same, right, for any web client request, but ultimately I need to associate, I need to ensure that the exchange filter function that's configured within this web client knows which specific authorized client to use to ultimately get the access token, set the authorization header. And I'm being explicit here, right? I'm actually providing it the authorized client. And what this is doing is it's ultimately just setting a request attribute within this specific request, right? And the exchange filter function looks for this specific attribute. If it's available, then it gets the access token, sets the authorization header, right? So that's one method on how to use web client. I'm going to show you another one later on when we do the client credentials grant. So that's pretty much what we need to configure to get, and just to do a quick recap here. I mean, it always starts with the client registration, right? We've done that. The next thing is our web client configuration, right? We associate, figure out which flow do we need enabled, the authorization code, configure our Auth2 client, or our exchange filter function with web client, right? And now in the controller, where we actually want to make the protected resource call, as you can see, I'm injecting my web client here. This is my web client that I configured there. And now the next step obviously is, I want to target a specific client, and this is one method, right? Then basically, we use it, and we configure the web client use this specific authorized client for this specific request. So that's pretty much it. So now if I restart this now, so what we've done is we've secured microservice A, microservice B, right? And now we've configured the one client here to go through the authorization code grant to get the token with the necessary scopes it needs to call microservice A, and then it's going to pass the token to A and B. Now we should be able to see if I didn't miss anything. We should be able to. I'm going to close this again. Just start fresh. We should be able to see some information being populated right now. Oh yeah, okay. So I did miss one thing here. What happened here is I have two clients registered, right? And what happens, as I mentioned earlier, if there's one client registered and there's an OpenID scope associated with that client registration, it just automatically triggers OpenID Connect authentication. If I have more than one client registered, then it displays the default login page with the 2 clients and showing the issue or URI. I don't want that, right? I know what client I've configured, right, for OpenID Connect. So I want to be able to automatically, have that same behavior when I try to access my UI app, just trigger the authentication. So what I'm going to do, I forgot to add a security configuration. So what I'm going to do, I'm going to do a checkout. Actually, no, I'll just add it here. I'll go security config. Okay. And then we're going to add this. Let's just import all these quickly, and I'll show you just quick what I was referring to, how we could trigger this quickly. And then I'm going to enable security. Okay. So now I'm going to get the behavior. Now let's take a look at this really quickly. As I mentioned, if you want to trigger authenticate, if you don't want that default login page and you just want to trigger authentication right away, this is how you would do it, right? This is the specific configuration that you would need to specify. So OAuth 2 login, that is the main entry point for OpenID Connect configuration. You just got to specify the login page. That's it, right? The default path is OAuth 2 authorization, and then you specify the registration ID identifier, so login client, right? Everything else here, it's pretty much standard Spring security configuration, but as far as OpenID Connect, this is what you need to specify. So let's restart that and try it one more time. Start it's fresh here again. I would do this. Okay, there we go, right? So now I'm going to log in. Make this bigger. Click on this. Okay, this is what we expected, right? This is where that annotation comes in, that registered authorized client. This client obviously is the very first time we're trying to access this client. It's not authorized, so it triggers the flow, right? And here we have client ABC, the client identifier that we configured wants to access your account, user 1. That's my unique identifier that I use to log in. These are the scopes I'm requesting. I'm going to submit consent and say, yeah, go ahead, I'm authorizing this client. And there we go, right? So now we have some data, right? Now we know that the UI app is configured with a client to go through the authorization code grant flow to request these specific scopes, which it ultimately could call service A and service B with that JWT, right? Because ultimately service A authorizes on authority A, service B authorizes on authority B, right? So there we go. So that's pretty much where we're at, right? Is if we come back to this diagram, now we've OpenID Connect authentication, we've configured, we've got another client that gets a token using the authorization code grant, calls microservice A, microservice B. The last part of this demo will be we're going to configure a client here, microservice B, using the client credentials grant to call microservice C. But before we get to that, are there any questions? Looks like we're good. Okay, so I'm gonna continue. Okay, so let's the first thing we're gonna do, we need to secure microservice C, and it's the
It looks like
same.
there's, sorry, it looks like
Oh
there's
yeah,
one
yeah.
question there
Oh, there is. Yeah.
in chat. Yep.
Let's see here. Okay, in the case of an expired token, a user has to log in again. Can you have the redirector be back to the place the user was when their token expires, opposed to if? Well, it depends which token you're talking about. So if it's the if it's the access token that's used to call the microservice, if it's expired, and because I've configured, let's go back to this configuration here. Because I configured refresh token, right? And because I have, if I look at this authorized client here, client ABC, as you can see, I do have a refresh token, right? So what happens is when that token is expired, right? Let's say, I'll make the assumption that the call is um, from the UI app, the client in the UI app, client ABC calling microservice A. If that token expires, it just automatically gets a new access token using this refresh token. So it's seamless. You don't see anything really happening. It's just seamless, right? So I think that is the question you were asking. Does that answer your question? Is it possible to have a resource server to validate tokens against two different authorization servers? I'm not sure why you would do that, because ultimately, and that doesn't really make sense actually, because when an access token is minted, right, there's one provider there, right? So you have to validate that that token with that one provider. So it's not really a valid use case where you'd validate with two authorization servers.
Yeah, I want to clarify. So basically, I was looking at,
Sure.
for example, if you have a migration process, migrating from one server to another one, so we have some time frame and we want to support two of them. So
Okay.
would that
Okay.
be a valid use case?
Yeah, so like maybe you're talking about where, you just got like two authorization servers. One's kind of like, maybe you're gonna take it down kind of deal. Is that kind of what you're
Yeah,
saying? Yeah,
yeah,
yeah.
that's right.
Yeah. Well, that's really an integration question, right? Like now those two authorization servers or those two providers, they obviously would have to be integrated, right? Along with the client application or the resource server that ultimately calls the provider. Can it be done? Well, you know what? Anything could be done. That's for sure, right? But the bottom line is this, right? Is the verification of that signature, the resource server just needs to get the public key, the right public key. Whether it gets it from provider A or provider B, it really doesn't matter. As a matter of fact, maybe what you would do is, I mean, that JWK set endpoint or the public keys are exposed, that could be another server altogether, depending on your setup, right? But the bottom line is that's really an integration question. The key here is the public key, the right public key needs to be fetched wherever that is, whether it's provider A, provider B, or maybe somewhere else, right? So that's kind of that's the answer.
Yeah, that's basically, see, because I understand that anything can be done. I was just looking if there was an easy on the surface way to do that, but okay, yeah, thank you.
Okay, yeah, no worries, no worries. Okay, let's move on. Let's move on to the next step, and then we could answer the rest of the questions after that, because we just got one section left here. Okay, so let's do this, right? We're going to secure microservice C, right? And then we're going to configure a client on microservice B to do the client credentials grant and ultimately get a token to call microservice C. So let's do that. Without I'm going to just kind of do this quickly. I'm not going to bother securing microservice C because it's really it's the same as A and B. So I'm not going to go through that and kind of waste time. I'm just going to check out this specific commit here. And I'm just force that so that way we're right there. And then I'm just going to restart things up. And then we're just going to confirm that C actually is secured, and then we're going to go through the configuration of the client after I get everything kind of started up here. Just kind of be in a fresh state, and we'll just make sure that we're back at where we're expecting to be. So I'm going to close this down. Let's just make sure everything's back up. Okay, that's what I want. Yep, that. Okay, so something is up here. Oh, yeah, no, that's right. No, that's exactly what I expected. Because yeah, yeah. Basically, what happened here is the client is calling. Sorry, there's a call happening to microservice C without a token, and we're getting this. But let's just double confirm. I'm going to try to access service C here. And we got the 401, right? That's exactly what we want. So that's where we're at right now. So let's set up that client in microservice B. So microservice B is a resource server, but now it's going to act like a client as well, because we're going to set up a client on the, we're going to configure a client, you know, in microservice B to ultimately, you know, call microservice C downstream service. Let's do that first. So once again, we're going to start with the client registration. So let's go to our application YAML here. Dependencies are there already, right? We have OAuth to resource server and OAuth to client. Now we're going to add our client here, our client registration. And we're going to use, you know, this looks pretty much the same as the other client registrations. The only one difference here is the authorization grant type. As you can see, client credentials, right? And it doesn't have a redirect URI because that's not part of the client credentials grant. There is no, you know, authorization flow, right? Because the client is representing itself, and it authenticates with the token endpoint, right? That essentially is the authorization grant, is the client credentials, right? The client ID and client secret, and so forth. So, and it's going to basically request authority C because it's got to call microservice C, and that's pretty much it, right? That's the client registration for the client we're going to configure in microservice B there. So that's it there. Now the web client configuration, it's the same. So what I'm going to do as a quick, I'm going to do a quick copy and paste of our oh, that's microservice, of our UI app configuration of web client configuration. Let's do that. Just grab that. And then the only difference here is I'm going to make this change, client credentials, right? So this client, this web client is configured with support for the client credentials grant. That's all I needed to do here, right? Now, the one thing that we also need to do is we do have to provide a custom security configuration for microservice B. And the reason being is by default, let me just add this first. By default, Spring Boot auto configuration, because I have resource server and OAuth2 client dependencies and properties configured, by default, it will auto configure OAuth2 resource server, OAuth2 client, and OAuth2 login, right? I don't want OAuth2 login, all right? That's not what this resource server capabilities are targeted for. So we need to provide a custom configuration and specify only OAuth2 client and OAuth2 resource server as such, right? We have OAuth2 resource server, JWT support, and then OAuth2 client, right? So that's what we specified that, and we specified our properties. And now in the specific flow, this specific flow here, this is the controller that gets called, right, for the client credentials grant. And this is the other method. I showed you the annotation, the registered authorized client annotation, how you could resolve an authorized client, you know, so you could use that, specify or use that client for a specific protected resource call. That was one method, right? The other method is, instead of using that annotation, you could just specify the client registration ID, right? Previously we had, you know, we had this, right? We had, right, and then we had the, I'm just going to put null there for now. We had, you know, we're specifying the authorized client as a request attribute because we resolved it via the annotation. If we don't want to use that argument resolver, we could just simply specify the client registration ID as such, right? And it performs the same thing. So those are two methods you could use with the web client. You could either specify the authorized client or the client registration identifier. Okay. So that's it. I think that's it for here, for our configuration. So we, you know, we specified the properties, right? We specified our standard web client configuration, right? The only thing we got to kind of fine tune is the authorization grant support. This one's just the client credentials grant. And then in our specific controller, right, method, or our specific, you know, spot in the code where we want to target a specific client, as the client to perform the authorization grant, to get the token, and ultimately make the access, the protected resource call. And this is where we specify the registration ID. So those were the three steps involved there. Now, if I restart this, restart microservice B, and we give this a try now, we should have, I'm going to start fresh again. I'll click on that. Yeah, I think I'm going to need to do this. Let's see what's going on here. Obviously missed a step.
I think you missed the security configuration annotation.
Oh, did I? Oh, okay. Thank you. Thank you. Yes, I did. Thank you very much. Okay, let's start that again. Okay, let's double check this. That's what happens when you go so quickly sometimes. Okay, let's go back here. Perfect. Yes, thank you very much. So let's look at this. So we know, right, the same token is being passed to service A and service B. There's the identifier of the token, the JTI, and then we could see it's a different one here, right? It's using our client C, right? And you could see here, it is the client credentials grant because the subject is the client identifier, unlike in the authorization code grant where it's the user, right? And there we go. So that's pretty much, I mean, we pretty much finished this demo. I'm going to do one last thing, the fine-grained authorization, right? Because right now, microservice A and B and C, they're simply just authorizing, allowing requests to proceed if the token is, first of all, valid, the signature is valid, and it's not expired. But you know, that's not really, I mean, we definitely want to be applying fine-grained authorization. We want to be able, we want that resource server to inspect the claims of the JWT and ultimately authorize the request based on, some conditional logic. Typically, it's scopes, right? However, there's a lot of different, use cases for, an authorizing, right? It just all depends on your authorization model within your application. You might not even use scopes. You might use custom claims that ultimately the provider, you know, is adds to the JWT and the resource server authorizes. It could be anything really, right? But we're using scopes here. So I'm going to basically show you how you would configure fine-grained authorization here. We're going to we'll go to the microservice C configuration, which is this one here. And we're going to add this one here, service B. Now I'm just going to put an invalid one for now, just to show that it's working. We're going to restart microservice B, and then we're going to expect to see a 403, right? Because ultimately service B, microservice B, authorizes on authority B. But this one's got, sorry, right now it's, it's authorizing an authority -B-2, right? But the token has authority B. So we're expecting a 403 here. So let's see what happens. And there we go, right? 403. So let's go back and restart that and just make sure that it's still working. And there we go, right? So now, we've specified some fine-grained authorization, right? Using scopes. That pretty much, that's pretty much the one thing I'm going to do is, because I've been showing client and resource server, I'm going to show you Spring Authorization Server, right? And what did I do to set up Spring Authorization Server for this application? And it's literally in one configuration file. Right, as you can see here, this is Spring Authorization Server. As you can see, there's nothing here, right? There's no Spring Boot auto configuration at this point. I got my Spring Boot application, standard, right? I got some utilities here, right? I need to have keys, right, to be able to, sign the JWT. So I added some utilities here that creates an RSA key, a elliptic curve key, a symmetric key. All right, these are just utilities that I'm using for the sample application. It has nothing to do with Spring Authorization Server. Spring Authorization Server, and then I'm going to come over here and I'm looking at my security config. This is Spring Security. This is not Authorization Server. As you can see, I've enabled forum login. I have one user, so I could authenticate with Spring Authorization Server. And then this is literally it, right, for enabling authorization server support, right? The main thing here is you got to import this OAuth 2 authorization server configuration, right? And what this does is it registers a security filter chain. It registers the authorization server security filter chain, right? And ultimately, what this is doing here is it's registering the token endpoint, the authorization endpoint, the JWK set endpoint, OpenID Connect discovery configuration endpoint, and so forth, right? It's basically saying, you need to be authenticated, standard configuration. It's ignoring, we're configuring a cross-site request forgery to ignore specific endpoints. For example, the token endpoint. When I do a post to the token endpoint, I don't want Spring Security cross-site request forgery filter to kick in. Right, I want to ignore that because ultimately the token endpoint will validate that request. Right, that, for example, the nonce is kind of like security feature within OpenID Connect that it uses as, to correlate the authorization request and token endpoint. Only the client could generate that nonce, right? So we want to be able to ignore, the cross-site request forgery filter for specific requests within OAuth, right? And, the token endpoint being one of them, right? As well as the client authenticating. But literally, there's a lot going on here. But from standing up an authorization server, that's all you really got to do for your configuration is just import that, right? And then the rest here is what you need to specify. Obviously, an authorization server needs clients or else it can't do anything, right? And as a matter of fact, your application is going to fail. You have to register a registered client repository. All right, as you can see here, the names are kind of, there's some symmetry there, right? On the client side, we have client registration, and then on the provider side, we have registered client, right? Similar configuration information, right? We need a unique identifier. You have the client credentials, right? We have the client authentication method supported, right? This client might support basic and post. We're definitely going to be supporting mutual TLS and JWT, private key and secret key support there. That's coming soon. Authorization grant support. This client could support authorization code. It could support, client credentials, and so forth, right? Refresh token, be adding more grant support. And the redirect URI, you can register multiple redirect URIs, for this client. You could register multiple scopes, right? And so forth, right? So here's my login client. Here's client A, client AB. These are all the clients for the full working sample, right? But this is the one that we were working with, right? As far as the client credentials flow. As you can see, I added, the 3 scopes, right? Because ultimately when the client requests scopes, it needs to request scopes that is registered to request, right? Or else, the request will get rejected. If this client tried to request authority D, it just, the grant would, there'd be an OAuth 2 error, the grant would not proceed, right? And so forth. So there's, that's the one thing you need to do as part of, standing up an authorization server. You need to register a bean of this type, registered client repository. Here, I'm just registering here, but this could come from anywhere, come from a database, wherever your clients are registered. All you need to do is implement this interface, find by ID, find by client ID, and that's it, right? And you register that bean. So that's the first step. Second step is keys, right? Where do the keys come from to sign the JWTs, right? This is the only other required bean, right? JWK source. Now this is a Nimbus. So internally we're using Nimbus for, the full Jose support. Jose as in JavaScript object signing and encryption set of specifications. That's where, JWS is, JWK, JWE, which is JSON web encryption, and so forth. So Nimbus is a third-party library that implements the Jose set of specifications. So authorization server support at this point requires JWK source, right? A source for JWKs, JSON web keys, right? And the only thing we need to provide is where do the keys come from, right? And what I have here is, I'm creating, a JWK set supplier, right? And there's a reason why I'm using the supplier, right? This enables key rotation. So for example, every time, you know, this JWK source is called, right? And it simply just delegates to the selector. This is where, okay, get me the JWK set, right? Supply it to me, each time this gets called, right? So, you know, even though this is statically defined here right now, I'm creating an RSA key, you know, I'm creating a JWK set, I'm always returning the same JWK set, right? This is static, right? Does not promote key rotation whatsoever. However, I could provide a supplier JWK set implementation that does that, right? Gets the keys from whatever backing source that may be, and you know, after you know, when that specific component triggers key rotation, then obviously when this get is called, it'll return the new um, set of keys, right? So this configuration here allows for key rotation. The only thing you got to do is implement the supplier of the GWK set that handles that implements, you know, key rotation functionality. Provider settings here. So this is not a required bean, but because I want to expose OpenID Connect Discovery endpoints so my clients and resource servers could self-configure itself, I need to configure the provider settings, right, with the issuer URI. This ultimately enables that configuration endpoint. And over here, I mean, there's a few things I could set up. If I look at the structure here, I could set, you know, I could customize the authorization endpoint URI, the token endpoint URI, the JWK set endpoint URI, and so forth, you know, token revocation, right? So this is ultimately, I mean, it's the provider setting, it's the global settings for the provider, right? Right now, it really is just housing the protocol endpoints, but this is really going to be the central point to configure your provider with all the different custom settings. But you know, just to recap, to stand up an authorization server, you import this, right? You specify a registered client repository bean, and you specify a JWK source bean. That's it, right? If you want OpenID Connect Discovery endpoint enabled, then you specify this bean. And that's pretty much it as far as standing up an authorization server. We are, yeah, that actually was an hour and a half. That's what I was planning. We started half an hour late, so I actually hit it right on. So that's it for me. But I'm going to take some questions, and if anyone's got any questions.
So which provider do you support recommend to us, whether it is a Spring or Keycloak?
Well, I'm going to obviously recommend Spring Authorization Server. But first of all, there's a big difference there, right? Is Spring Authorization Server, it's a framework, right? It's not a product. You have to build the product on top of Spring Authorization Server. Keycloak is a product, right? It is a full-blown provider. So you can't really, it's not a true comparison. But like I said earlier, right, you do not want to be, I mean, unless you're in the business of you know, building an OpenID Connect provider like Okta, like Keycloak, then fine, right? But but I highly would not recommend to, you know, use Spring Authorization Server to build your own authorization server and then put that into production. That is not a good idea, right? Really, you know, like I said, the biggest use case of Spring Authorization Server is for developers to test their client applications and resource server applications. There's definitely, I mean, not definitely, I hope there's going to be companies out there that are going to look at Spring Authorization Server and say, you know what, we're going to build a provider on top of Spring Authorization Server. Instead of dealing with all these underlying protocol implementation, all these grants, different ways clients authenticate, we're going to let Spring Authorization Server do that. And on top of that, we're going to build the value add features, right, that providers provide, right? So that really is the two areas that Spring Authorization Server is meant to be used for: developers for testing and developing and so forth, and companies that specialize in the security domain, specifically OAuth 2 OpenID Connect, that have their own products. So yeah, hopefully that answers your question. Here's another question here. Is it possible to include custom claims in the authorization server? Definitely. I mean, that's a definitely an MVP, requirement for sure, right? You need to be able to customize the JWTs and ultimately the claims, even the headers, right? You need a hook to be able to specify custom claims. So that is coming. We're actually working on that. That will be part of 010 release, which is targeted, I think, February 11th. I got a PR out there that I'm just going through with a couple of my colleagues. We're just working out, ironing out the design there, but that will be in 010. There is a ticket out there for that, so just keep an eye out for that, and there will be samples. Like, for example, one of the common cases is I want to be able to populate the user's authorities, right, as a custom claim in the JWT. So for example, if the user authenticates and they're in role A, role B, I want that role A, role B to be a custom claim called roles in the JWT. Like, that is so common, that one, right? So you're going to be able to do that. There will be a sample there. It's not there yet. Just keep an eye out. It will be in 010 release coming up. No worries. What do we got here? Are there any commercial auth server vendors that are planning to build on top of? I have no idea right now. I mean, this is still experimental and it's still really evolving, and there's still going to be a lot of refactorings. Pretty happy where things are at right now, but it's going to change a lot more over the next year. So we definitely have, two products within VMware that are building on top of it. Can't get into those details, but that's definitely helping us really refine it. But yeah, that is the goal, right? More vendors will, build on top of Spring Authorization Server, but it's still early for sure. No worries. Are there any annotation-based approach? No worries. Are there any annotation-based approaches for constraining certain endpoints with, say, scope requirements? Yeah, I mean, I showed you, using web security, right? Using the security configure, using HTTP security, and defining the authorization rules there. Spring Security offers method security, right? So you could use, the pre-authorized tag, and it's the same thing, right? You pre-authorize, and then it would be like, if I go back to my security config, which one was it? It was the microservice B one. Yeah, it was this one here, right? So you would use the same, in your pre-authorized tag. You would specify that in your pre-authorized. That should work. Do I have a sample? No. Or maybe there is one. I can't recall at the moment, but that should work. If it doesn't, log an issue and we'll look into it, but that really should work. Okay, let me just make sure I didn't miss anything here. Okay, I answered that, yep. Okay, the next one here is, we've got an old MVC monolith and migrating pieces off to Spring Boot microservices. Can we have the resource provider auth without upgrading the whole monolith to? Can we have the resource provider auth without? I'm not sure I understand that question. If you could.
Yeah.
Yeah.
Sorry, I mean that. Is it possible to do the security between the microservice, or between the monolith and the microservices without doing the whole thing, like without upgrading the whole monolith to a more modern Spring Security?
Well, yeah, there's definitely, I mean, I mean, typical strategy, is, with your monolith, you start decomposing it, right, into its, finer grained services or resource servers, right? So, if you, I'm just going to use a typical example. We're just going to call it, it's a shopping cart application, right? It's a monolith. We want to extract the inventory service into its own microservice, right? So we'll decompose that feature or that specific function into its microservice, right? Now we've created this microservice. Now the only thing we got to do in the monolith is, just like what we were doing in this application is, if we look at this diagram, right, in microservice C, let's say that is your, decomposed feature, right, your inventory service, right, and let's just imagine UI app is calling actually, you know what, let me just backtrack. Let's say microservice A is the inventory service. UI app is the monolith, right? Now, the only thing you really need to do is you have to configure the monolith to, have configure it as an OAuth client to ultimately call microservice A, right? So now that would be your approach, right? So, now your request to your inventory service is secured by OAuth, right? And everything else is, status quo. And you just keep kind of doing that incrementally. Does that make sense?
Yep, that's great. So you can kind of mix and match some of these scenarios that you've been explaining.
Oh yeah, definitely. No, yeah, you could easily mix and match. Different. There's so many things. There's so many things you can do. Yeah, no, you could definitely mix and match for sure. Yep.
Great, thanks.
No worries. Spring Security OAuth to auto configure. That just. Sorry, I'm not sure if I understood that last one. Yeah. Not really. I guess I'm not seeing that as a question. That was in reference to my last question. Sorry, which was this? Which question? Oh, with annotations. I gotta go back to the. Would you mind speaking up? It'd probably be a lot more efficient because I'm not quite getting it.
Yeah, sure. So we just kind of had a project with some of that code that was kind of using this as a way to kind of annotate things.
Okay.
And from what I understand, it's in maintenance modes. So, and there was a mention for using Spring Security 5 with OAuth. So I'm just wondering if you had an opinion on that approach. You
Oh
sort of
yeah,
covered
yeah.
a little bit with the
Okay, I
database
see
thing.
what you're saying right now. You're talking about the enable authorization server, enable resource server. You're talking about
Yes,
those.
yes.
Yes. Okay. Yeah. I'm not sure if you saw the announcement, but so Spring Security OAuth, the legacy project, the one that's been around, right? The one that we basically rewrote with the new OAuth client support that now is in Spring Security since 5.0. That auto configure dependency uses the legacy one. And that really was just added to add Spring Boot 2 support. That's really the whole purpose of that dependency. But that's going away too, just like the legacy one, because that uses the legacy one. So there is an announcement. Did you see the announcement, the end of life notice for legacy OAuth? Did you happen to see that? No, or?
I was aware of it a little bit, yes.
Okay. You know what? I'm gonna put it in the chat here, just so you could see it and then you could read it. Where is he here? Yeah, this one here. I'm gonna put this in the chat. Take a look at this. And the bottom line is this project's gonna be reach end of life. It's next year sometime. I can't remember now. It's in the post, but you really should migrate to the new OAuth client support because this will not be supported at some point next year. We've already reached feature parity with client and resource server. Authorization server support is going to reach feature parity by mid this year. So all the features are going to be available that are available in the legacy stuff. by middle of this year, but they already are available for client and resource server if that's all that you're using. And there is no annotate, like there is no equivalent of enable resource server. The way to enable resource server with the new support is exactly like this, right? OAuth to resource, OAuth to resource server, OAuth to client, right? That's how you enable, you know, OAuth client or resource server, and eventually OAuth to, you know, for authorization server, you're going to have this, right? OAuth to authorization server equivalent, right? So that's how you do it. That's how you enable OAuth client resource server in Spring Security. It's very different. It's a complete rewrite, but in that post, and yeah, in that post, there's a bunch of links that really reference everywhere, but there is a migration guide. There's quite a bit of documentation out there, and if you can't find it, then login issue, even though we don't really take questions on Stack Overflow, it's more about bugs and enhancements, but if you can't find it, login issue anyways, and then we'll respond to you pointing you to the migration guide and the documentation, but it should be in that post. But if it isn't, yeah, just post a question on GitHub or an issue on GitHub. Oh, somebody just posted it. Perfect. Thank you. Thank you, Ambu. Any other questions? We should probably wrap it up. I'll take 2 more questions if there are any more. Right now there isn't, but I'll take 2 more and we should probably just wrap it up. It's like way past my bedtime here.
Yeah, hey Joe.
Yeah.
It looked like there was some code in the web client that registered service C or the auth C. And it also looked like in the configuration of the resource server that all of the services or the authorities were registered in statically in the code. Is there a plan to do dynamic registration of like service topologies so that a client doesn't have to know about, you know, service B connecting to service C, and so that the registry doesn't have to know about the topology?
Yeah, there's actually a PR out there for implementation of OpenID Connect, that dynamic client registration. So that's coming, right? Like honestly, um, this is not like registering your client, you know, in your application YAML like this with your secret is not recommended whatsoever for a production application. But you know, this is what gets you going, right? But really, for any production application, um, and keeping things as secure as possible, you really don't want to take advantage of Spring Boot auto configuration that reads these properties and literally registers an in-memory client registration repository, whether it's on the client or authorization server. Either you provide that bean, right, and that bean knows where to get, you know, all those, you know, all the client registration information, especially the private information like the client credentials, and it just gets it from a secure environment, right? So that's the first thing. But is, you know, we're once again, I'm pretty excited about this one POC I'm going to do in February. Is I'm going to put together, we got this PR for dynamic client registration, right? And I'm not sure if you're familiar with Spiffy, right? So Spiffy is an implementation of PKI within the Kubernetes environment. And you know, ultimately, I'm going to put a POC together that integrates with Spiffy, where the authorization server starts up, exposes a dynamic client registration endpoint, and that client, when the client is registered, it integrates with Spiffy to ultimately obtain a private key and a client certificate, right? And then it uses that client certificate to authenticate with, you know, basically within, authenticate with the resource server or the authorization server, right? Dynamically, right? So nothing's registered. And Spiffy handles revoking client certificates, renewing them. It does all of that for you, right? So ultimately, what would happen is the authorization server doesn't store any credentials whatsoever. I mean, the user database is stored with the external provider, whether that's SAML, LDAP, whatever. Then the authorization server, instead of it's storing the client credentials, whether it's client ID, client secret, um, or a client certificate, um, but in this specific POC that I put together is, Spiffy manages that. So now this specific authorization server deployment POC that I put together doesn't store any credentials whatsoever. So like that is a beautiful thing, right? Because, you're just delegating, external subsystems that manage the secrets, right? So hopefully that answers your question.
Yeah, it does on one respect, but we might have run out of time as well. I was thinking about the Java code where the registration is done in Java statically, where you're defining authority A, authority B, and authority C
Oh, okay, in the
in
authorization
the web
server?
client code. Yeah, and also in the registration server was doing it as well. Yeah, there you go.
Yeah. It's the same, like I mentioned, so this registered client repository, this is the required bean. So for production application, you would not do this, right? You would have your own implementation of registered client repository. You just need to implement this interface, pretty simple interface, right? And it would provide all that information wherever it gets it from, right? So that's what you would do for a production application. You would obviously not do this, right? Bake
Yeah.
the secrets in the code, in the compiled code. You would never do this, right? But this is what we do in samples and demos and so forth. So that's what you would do on the client and on the authorization server. Just register the bean, and the bean provides that information wherever it gets it from, obviously from a more secure environment, right?
Yeah, it sounds good. It'd be good if the demo could move in that direction as well, because then you don't have that tight coupling in Java code.
Yeah, I mean, the thing I mean, sure, I could provide a JDBC version of it, but the thing is every application is going to be different, like where they store there's so many different storage mechanisms, right? Whether it's Redis, JDBC, or maybe it's external service, right? So there's too many use cases. Like Spring Authorization Server or Spring OAuth client is not in the business of supporting all these backing stores. That has nothing to do with OAuth, right? That has to do with persistence, right? All we do is provide an interface and you provide the implementation, whatever that backing store is, because you could easily store things in LDAP, right? I mean, I don't know if you would, but you might, right? So that's yeah.
Yeah, that's good. That's good enough for now. Yeah, thank you very much
Yeah,
for the
no
talk.
worries.
Yeah.
No worries.
Hey, Joe, is there any piece of information that you'd like us to carry out and share with our networks out there? Anything that's you find important or critical?
Well, the one thing I want to share is obviously the repository of the demo, right? So this is the main repository. Um, the demo that I used is on the demo branch, right? And if you want to do this on your own, check it out on your own, um, you know, this is basically where master is right here. And as you can see, remove security UI app, remove security, right? This is where we started, right? No security. And then I incrementally built, added the security back in, enable OpenID Connect and so forth. So, check out this repository. Like I said, the whole purpose of this repository is really to learn how to integrate client resource server and now authorization server. So that's really all I really wanted to.
Can you put
Yeah,
that URL in the chat so we can
sure.
get
Yeah,
it out? Cool.
let's do that. And then I'll also share the repository for Spring Authorization Server as well. And you'll see in the demo repository, there's links here to the reference documentation for client, OpenID Connect login, Auth2 login, and then Auth2 resource server. And here's some links to some samples as well. These are more smaller samples. This sample really, has all the pieces together. It's the more advanced real world sample. But that's pretty much it. Yeah, there's nothing really else that I needed to share there, or I wanted to share. Yep.
Cool. That was really interesting.